The purpose of this talk is to review fractions. I know that most of you learned fractions probably back in elementary school, but I've learned through the years that it's amazing how many things we can forget how to do certain things. And in this case, especially a lot of times in math, we'll have problems that involve what we call complex fractions, which I'll get to in a few minutes, which can be a little tricky. But instead of just explaining complex fractions, I thought I would just do a quick review of fractions, talk about some of the math language. There are a few things with fractions that I see students mess up on or don't quite understand. So I'm just going to quickly highlight those. So my apologies if some of this will seem pretty trite and simple. I actually began this talk earlier and my camera was not focusing well. So instead of redoing some of what I wrote, I'm just going to step through some of what I've already done. So here we go. This is a fraction review. And the first thing I want to do is sort of define some of our terms with fractions. So here's a typical fraction, 2/3. Now in the math world, the top of the fraction we call the numerator, although sometimes you'll hear me just call it the top. I'm a simple man, and sometimes I just like to explain things simply. And then the bottom is officially called the denominator. But once again, oftentimes you'll hear me just say the bottom. So I'll go back and forth. Now, when we think about fractions, one of the things you learned way back, here we have the fraction 4/2. Fraction really is the exact same thing as division. Anytime you have a fraction, if you want to, or even in your head when you're looking at a fraction, matter of fact, you probably do this and don't even think about it anymore. 4/2 is really the same thing as 4 divided by 2, which of course equals 2. Therefore, we say the fraction 4/2 simplifies to 2. We're really dividing here. That becomes important when we do some problems later on. Now, some of the confusion I've seen in the past are when we have negative fractions, because it can be a little tricky where they put the negative sign. In textbooks and even as the teacher's doing problems, seems like the negative sign moves around and it can be a little confusing. So for instance, sometimes you'll see a negative fraction written like this. You'll see the fraction and the negative sign is sort of way out front, sort of in the middle in a sense. That is negative 2/3. But then you'll also see sometimes, you'll see the negative sign moves up to the top or the numerator. Well, that fraction is negative 2/3. These are exactly the same. Even though the negative sign is in a different place, they're the same. And theoretically, although you don't see it as much, but sometimes it happens where you end up having the negative in the denominator. So these three fractions are all the same. They're all a negative fraction. Now, sometimes, every once in a while, I see students do something like this. They'll see a negative fraction, and they'll want to sort of move the negative next to the numbers. And then sometimes they'll do something where they think, well, you need to put the negative sign in both the top and the bottom. Now, of course, you can't do that because hopefully you realize that -2 divided by -3, when you divide two negatives, it's a positive. -2 over -3 is actually 2/3, which is obviously not the same as -2/3. So if you move this negative sign around, it can go to the top or the bottom, but it can't go to both. All right. Through the years, I've seen students occasionally get confused because that negative sign can sort of move around. Now, one of the things you learned to do years ago when you first learned fractions was called reducing fractions. It's another way of simplifying. So 2/4, most of you look at that right away and you say to yourself, well, that reduces down to 1/2. And you learned years ago when you were solving problems that if you got an answer of 2/4, you would not leave that as your final answer. You were taught, probably since you quit taking your bottle as a child, well, maybe not that early, but you were taught way back when that you always reduce a fraction. Now, the way we reduce fractions, maybe you do or don't realize this, or maybe you just do it subconsciously because you've done it for so long. Basically, you have to look at the number in the top and the bottom, and you have to find a common factor. Common factor means a number that goes into both the top and the bottom. So for instance, 2/4, common factor would be 2. So 2 goes in the top and 2 goes in the bottom. Another example I did here was a little trickier, 9/51. You first look at that and you ask yourself, does that reduce? Maybe at first it's not obvious. So you have to start thinking about numbers that go into 9 and see if that same number goes into 51. In other words, do you have a common factor? Well, 9, it's pretty simple. You can divide it by 3, and that's pretty much about it. So you look at 51 and you say, well, can 51 be divided by 3? And as it turns out, it can be. So in a sense, when you reduce it, you divide the top by 3, you divide the bottom by 3, and when you do that, 9 divided by 3 is 3, 51 divided by 3 is 3, you get 17. So 9/51 reduces down to 3/17. All right, I think most of you know how to reduce fractions, but just trying to cover all the bases to prepare for some future stuff. Now here's where I stopped when I realized that my camera was going bad, so I can now just start to write. Let's go through mixed numbers real quick. It's actually interesting in math. You rarely ever solve problems leaving a number in the form of a mixed number. Typically, we always change this to a true fraction. In other words, sometimes we call this the whole number part, and we'll call this the fraction part. That doesn't show up too clearly. Let me use a different pen. So anyways, we want to change this to just a simple fraction. So what we'll do is, there's a little, I'll go over it quickly, but I'm not going to write it out. The way you change the mixed number into a pure fraction, you take your whole number and you multiply it by the denominator. So in a sense, you have 2 times 3, and you take that and you add it to the initial numerator here. So 2 times 3 plus 2, 6, 8. So 8 becomes your numerator, and then of course your denominator stays what it was here. So 2 2/3 is the same thing as 8/3. And when you're actually solving problems with fractions, you need to have a true fraction. It's really a pain, and it's not a nice thing to try and solve problems, to do calculations with mixed numbers. So you almost always will convert a mixed number into an improper fraction. Just for fun, what if I have 10 4/5, and I was going to do some kind of calculation. I need to convert that to an improper fraction. 10 times 5 is 50 plus 4. 54/5. Now it's interesting. You may run into this occasionally. Say you have it, this is called an improper fraction. Improper fraction is where the top is larger than the bottom. We can always convert an improper fraction into a mixed number. And the way that you would do that is you would take 54 divided by 5. 5 can go into 54 10 times, and there's a remainder of 4. If you go back and remember about remainders and division, so you put your remainder up here, and then you have an improper fraction. All right, not spending more time on that. There will occasionally be problems in your math classes where you have a mixed number. Something that students trip up on, which I'll just cover it now. First of all, let's just do a quick review of math operations with fractions. Two-thirds plus 3/4. How about if we subtract them? How about if we multiply them? How about if we divide them? Right? So the 4 sort of major math operations when we're using fractions. When I used to teach this many years ago, I would always do the easiest first. Of these 4 operations, do you know what I think is the easiest? What most people think? The easiest is whenever you multiply 2 fractions. Why is that? What do you do when you multiply fractions? You multiply the tops and you multiply the bottoms. And then, of course, in this case, we'd reduce it to 1/2, right? Multiplication is easy. Multiply the tops, multiply the bottoms, and you're done. I would say the next easiest is division. Now, this is going to become important in a few minutes when we talk about complex fractions. So now's a good time to review. If you remember how you were probably taught to divide fractions is you write, copy down, rewrite the first fraction. Instead of division here, we're going to switch it to multiplication. And then we're going to flip or take the reciprocal of the second fraction. So in other words, 2/3 divided by 3/4, we can rewrite as 2/3 times 4/3. So the rule, hopefully you remember now, is that when you divide 2 fractions, you simply take the first fraction and you multiply by the reciprocal of the second fraction. So you simply flip the second fraction. And now we have a multiplication problem, which we like, because you just multiply the tops. 2 times 4 is 8. 3 times 3 is 9. 2/3 divided by 3/4 is 8/9. Now let's go back up here. The reason why we save addition subtraction for last is because in order to add or subtract fractions, you have to have a common denominator. Remember that, a common denominator. So of course, I'm not going to take the time to go into common denominators, except to say, when you look at 3 and 4, I'm looking for the smallest number that 3 goes into and 4 goes into. Hopefully most of you realize that it would be 12. So what we're really doing, and maybe you've done this for years and not really thought about it for a long time, I'm going to take each of these fractions individually, and I'm going to convert this fraction. Here I've got the fraction of 2/3. Instead, I want that fraction to have a denominator of 12. Well, what do I have to do? What do I multiply by 3 to get 12? I multiply by 4. But of course, if I multiply the bottom by 4, I have to multiply the top by 4, because I can't really change the value of this fraction And if you multiply by the same thing in the top and the bottom, 4 over 4 is 1. So when I multiply the top and the bottom both by 4, I'm really multiplying by 1. So I'm not changing the actual value of this. I'm just changing the way it looks. So 2/3 becomes 8/12. 2/3 equals 8/12. And then I do the same thing to my second fraction. This 3/4, I want the denominator to be 12. What do I have to multiply by 4 to get 12? By 3. So therefore I have to multiply the top by 3. So 3/4 now becomes 9/12. Now the rule for adding or subtracting fractions is, if you have two fractions with the same denominator, unlike multiplication where you multiply the denominators, when you add or subtract, when you have the common denominator, your final fraction, you just simply copy down the common denominator. Please do not add the denominators. You simply write down the common denominator, and then you add the numerators, 8 plus 9. So 2/3 plus 3/4 equals 17/12. So subtraction is really the same thing. You have to get a common denominator. So of course these fractions are going to be the same as this. So in this case, if I subtract, once again, you write down the common denominator, 8 minus 9 minus 1/12. Now, while we're doing this, let me do a little subset, because sometimes, once again, through the years, students stumble when they have to do some math with fractions because it's been so long. Here's one common kind of problem that students sometimes get confused about and end up doing it incorrectly. This is very common. What happens if you have a whole number times a fraction? Well, let me show you what it is sort of theoretically, and then I'll sort of give you the shortcut. Theoretically, the way you think about this, let's convert this 4 to a fraction. Anytime you have a whole number and you want to write it as a fraction, you can always just put it over 1, right? 4 over 1 is the same thing as 4. So I can say 4 times 2/3 is 4 over 1 times 2 over 3. Multiply two fractions, 8/3. However, most of us don't do this. When you do this long enough, it's almost like a shortcut. And the shortcut, or the quick little rule, is when you multiply a number times a fraction, you take the number, the whole number, times the top, times the numerator, and then divide it by this denominator, which is essentially what we're doing here, right? 4 times 2, 1 times 3. Instead of doing this, normally you just take the whole number times the top divided by the bottom. So if I have 2 times 7/4, 2 times 7 is 14 over 4. Of course, here's another example I just made up that you would have to reduce. So 2 times 7/4 is 7/2. Just for fun, what would happen if you have 2 divided by 7/4? Here, the shortcut is not so simple. What you would do, once again, turn the 2 into a fraction. So we have 2 over 1 divided by 7/4. But of course, whenever we divide fractions, we multiply by the reciprocal. So when you get all done, 2 divided by 7/4 is 8/7. All right, so that brings us to really the final review of fractions. And this is really what you're actually going to use a fair amount. And that's called a complex fraction. So this is going to be about how to simplify complex fractions. And there can be typically 3 kinds of complex fractions. The first kind, complex fraction, means you have a fraction over a fraction, right? So you got sort of an overall fraction. You can think of 1/2 as being the numerator, 2/3 as being the denominator. But instead of having a traditional fraction where you have a number at the top and a number at the bottom, instead we have a fraction at the top and a fraction at the bottom. Now, in the world of math, you would never leave this as like an answer to a problem. In the world of math, you would say we need to simplify this expression. We don't leave it in this form. It's almost like, if 2/4 is your answer, you need to reduce it to 1/2. You don't leave it as 2/4. Same thing here. You don't leave it as a complex fraction. Well, that's the first kind of complex fraction. Let me write down the second kind of complex fraction. How about sometimes you actually have a number in the top, but then a fraction in the bottom? This is also called a complex fraction, and we would not leave the answer in this form. Or when I say not leave the answer, oftentimes you're doing a math problem and you come across this, you need to simplify this just so that you can more easily finish the problem. When you come across something like this in a problem, you don't want to leave it like this. That can make the math more difficult. What you first do is simplify these complex fractions and then finish the problem. So there's a third one, which maybe you would have guessed. Sometimes you might have a fraction in the top and simply a number in the bottom. So these are all complex fractions. So let's take a minute and talk about how we simplify them so that when you come across these in class, you'll know what to do. Let's take the first one. 1/2 over 2/3. The whole key, let me show you the theory behind how we simplify this, and then we'll talk about how to do it as sort of a shortcut. So the whole key is to realize that a fraction can be rewritten as division, right? So I'm going to take 1/2 as my numerator, just like 2 over 4 can be rewritten as 2 divided by 4, right? I can take 1/2 and divide the numerator or the bottom. So I'm simply taking sort of the overall fraction and rewriting the fraction as a division problem. So now I have a division problem of 2 fractions. And how do we divide 2 fractions? Well, you write the first fraction and you multiply by the reciprocal of the second fraction. So at this point, if you multiply these fractions, we get 3/4. So this complex fraction, 1/2 over 2/3, simplifies down into the fraction 3/4. And this is sort of the theory, the reason it works. Now, what'll typically happen when you're actually doing a problem, sort of the shortcut is, you say to yourself, first a complex fraction, fraction at the top, fraction at the bottom. You simply write 1/2 times the reciprocal of what's in the bottom, and then you're done. In other words, you don't need to write out the division part of it. You can just go from the complex fraction immediately to this. All right, let's look at these two other examples. How would we simplify this complex fraction? 2 divided by 2/3. Well, here's one way to think about it, and maybe I'll give you a couple alternatives. One way to think is we know what to do now. We have a fraction over a fraction. Here we got a number over a fraction. How about we go ahead and convert that into a fraction, right? Anytime you have a whole number, you can always turn it into a fraction. And now we have sort of a complex fraction like we just talked about. So you write the first fraction multiplied by the reciprocal of the second fraction. You'd have 6/4, which would reduce to 3/2. Now, sort of a shortcut way when you have this, which hopefully a lot of you can see and understand. I mean, you can always do this if you're not sure. But a little shortcut way is if you have a number on the top and a fraction on the bottom, you can just take the number and multiply it by the reciprocal of the denominator, or what's in the bottom. You know what? I made a mistake here. Whoops. I don't know why I wrote that. You probably saw this, because now I'm seeing my answers are different. For some reason, when I took the reciprocal here, I made it 3/4. Should be 3/2. Sorry about that. It's not good to make mistakes like that. So this is 6/2. This is 3. I knew this was wrong because when I did this one, I'm saying, whoops, this answer is not the same as that one. It's the same problem. So now, once again, the number over a fraction, sort of a shortcut is you take the number times the reciprocal of this fraction. 2 times 3/2, you can think of these as canceling out, and you get 3. All right, sorry about that. Now, one last thing to look at. What happens if you have a fraction in the top and a number in the bottom? Okay, let's talk about that, and then I think we'll be done with this review of fractions. So how about simplifying 1/2 over 3? Once again, if we do it sort of in what I call the theoretical sense, or we go through the steps, I could rewrite this 3 as a fraction, 3/1. A complex fraction where I have a fraction over a fraction, I can turn into a division problem. Of course, a division problem is where you multiply by the reciprocal. You go through all these steps, it's 1/6. Now, normally you don't need to go through all those steps. Now here, this one's a little tricky. So here's what I do normally. I'm not, I would say a lot of you, just to make sure you don't mess up, when you see something like this, I would suggest you sort of turn this into a fraction and then do the old, take the top, multiply by the reciprocal of the bottom, and you get the answer. When you've done this for as many years as I have, when you have a fraction on the top and a number on the bottom, the really super shortcut is you simply take the bottom and you multiply it by the bottom of the fraction in the top. So I have 1/2 divided by 3. I say, well, the 3 gets multiplied by the 2, and you get 1/6. So for instance, if I saw this in a problem, and because I've done this for so long, I just say to myself, well, the 3 is going to come up here and multiply by the 7. I'm going to have 5/21. All right. So this is like the super shortcut. But if you can remember it and do it correctly, it makes it even simpler. But if you can't quite remember this all the time, you can always, my suggestion is to be safe, you can always do this, which really isn't that much work either. All right, just for fun, let's do one last problem. How about 2 2/3 divided by 1/4? How do you think we would go about simplifying that? So I got a mixed number in the top, fraction at the bottom. So it's almost like I have a complex fraction, but as a part of the complex fraction, I have a mixed number. First thing you would do, I said a few minutes ago, mixed numbers, we hardly ever do any kinds of calculations with a mixed number. You always need to first convert it to a fraction. So if you recall, 2 times 3 is 6, plus 2 is 8. 2 2/3 is 8/3. So we have 8/3 over 1/4. And now our rule for complex fractions is you take the top, multiply by the reciprocal of the bottom, 32/3. And just so you know, one last thing I'll say, whenever you give an answer, improper fractions, that's what this is called, where the right where the top is bigger than the bottom, that's almost always a perfectly fine answer. They would never, hardly ever expect you to convert this into a mixed number. Just leave it like this, and then you're good to go. All right, so when you work problems, you're going to come across lots of problems with fractions. So hopefully this little review has helped you, and you can make sure you don't make any math errors as you're working through these problems.